Welcome to the DIY Honda Garage channel. DTC P0571 refers to a malfunction in the brake pedal position switch circuit of the Honda Pilot from 2016 to 2022. The brake pedal position switch plays an essential role in ensuring that the vehicle's brake lights operate correctly and send appropriate signals to the Engine Control Unit, ECU. This switch is typically located on the brake pedal assembly near the dash and interfaces with the Powertrain Control Module, PCM, which governs engine management based on brake status. If this circuit is malfunctioning, it may incorrectly signal whether the brake pedal is engaged or not, potentially affecting safety systems and driving performance. Understanding this DTC is crucial, as it could lead to unsafe driving conditions if not properly addressed. DTC P0571 signifies a malfunction in the brake pedal position switch circuit, essential for the correct operation of the vehicle's brake lights and interaction with the PCM. The brake pedal position switch is situated on the brake pedal assembly, typically just a few inches from the pedal itself. This switch sends electric signals to the PCM, which processes the input to determine when to engage or disengage certain functions within the vehicle, including the activation of the brake lights. If this circuit experiences issues, it could prevent the brake lights from functioning correctly, leading to potential accidents. Given its critical location and function, it's essential to troubleshoot effectively whenever this DTC is set. Several factors can lead to the manifestation of DTC P0571. One possible cause is an open circuit within the wiring, which can occur due to wear, corrosion, or physical damage that disrupts the flow of electricity. Another likely culprit is a faulty brake pedal position switch itself, which may not provide the correct signal to the PCM when the brake pedal is engaged or disengaged. Additionally, a blown fuse can interrupt the circuit, causing the PCM to fail to receive accurate information from the brake switch. Identifying which of these issues is present can guide the mechanic in executing the appropriate repair actions. It's essential to investigate each of these possible causes systematically to ensure a thorough resolution. When DTC P0571 is triggered, various symptoms may arise, indicating an underlying issue in the braking system. One of the primary symptoms is malfunctioning brake lights. They may stay on continuously or fail to illuminate when the brake pedal is pressed. This can compromise vehicle safety, as other drivers may not be aware of your intent to stop. Erratic engine behavior may also occur due to the PCM not receiving accurate input regarding the brake status, potentially affecting acceleration and other driving dynamics. Additionally, you may notice warning lights illuminate on the dashboard, signaling to the driver that a critical system requires attention. Recognizing these symptoms early can assist in diagnosing the underlying problem effectively. The first troubleshooting step for DTC P0571 involves checking the brake lights without pressing the brake pedal. You should visually inspect whether the brake lights illuminate when the pedal is not engaged. If the brake lights remain on in this state, it suggests a potential malfunction within the system, indicating that the circuit is shorted and you should proceed to step 9. Alternatively, if the brake lights are off, it confirms that there is an issue that needs rectification, and you will move on to step 2. This initial assessment is crucial, as it quickly distinguishes whether the problem originates from the brake lights being improperly activated or if it relates to other components in the circuit. For the second troubleshooting step, check the brake lights while pressing the brake pedal. This validation will reveal whether the brake lights are functioning as needed when the brake pedal is engaged. If the brake lights illuminate correctly in this scenario, you should proceed to step 3. Conversely, if the brake lights do not turn on, it indicates a possible failure in the brake light circuit, leading you to Step 5 for further evaluation. This step is vital for determining where in the circuit the malfunction may lie, ensuring a systematic approach to troubleshooting. In this third step, we turn the vehicle to the on mode and check the brake pedal position switch signal using the HDS, which stands for Honda Diagnostics System. At this stage, verify if the parameter reflects a change when pressing and releasing the brake pedal. If the signal does correctly toggle between on and off, this indicates that the brake pedal position switch generally operates correctly, but it suggests intermittent failure. At this moment, checking for poor connections or loose terminals at both the brake pedal position switch and the PCM is essential. If the freeze data or onboard snapshot is recorded, try to reproduce the failure under those conditions for a more profound understanding. If the signal does not change as expected, skip to Step 4. Step 4 requires checking for an open wire in the stop SW line. Turn the vehicle to off, lock mode, and jump the SCS line with the HDS before waiting for more than 1 minute. Next, disconnect the PCM connector A to perform a voltage test. When you press the brake pedal, measure the voltage between test points 1 and 2 while ensuring the vehicle remains in the off mode and the PCM connector A stays disconnected. If battery voltage is present between those test points, it shows the stop SW wire is functioning correctly. However, if there is no battery voltage, it indicates an open circuit in the stop SW wire and necessitates repair between the PCM and the brake pedal position switch. The fifth step involves testing the brake pedal position switch itself. This is done by performing a direct test on the switch to confirm if it operates within specifications. If the switch is deemed normal, then the troubleshooting can continue to Step 6. Alternatively, if the brake pedal position switch is found to be faulty, the switch will need to be replaced to resolve the issue. This test is crucial, as it assists in identifying whether the problem lies directly with the switch or elsewhere in the circuit, ensuring accurate diagnosing and subsequent repairs in line with DTC P0571. In Step 6, it's essential to check fuse number A6, rated at 10A, located in the underhood fuse relay box. This fuse protects the electrical circuits associated with the brake system, including the brake pedal position switch. If the fuse is intact and functioning properly, the troubleshooting will proceed to Step 7. On the other hand, if the fuse is blown, it will require replacement, and it's advisable to check for any underlying issues that may have caused a short to ground within the circuit of the number A6 fuse. Replacing the fuse alone without assessing the circuit could lead to repeated failures, so a thorough inspection is a best practice. The seventh troubleshooting step focuses on verifying voltage at the +B stop line. Ensure the vehicle is in off-lock mode and measure the voltage between test points 1 and 2. Test point 1 is at the brake pedal position switch 4P connector number 2, while test point 2 is connected to body ground. If battery voltage is present when the brake pedal is pressed, it indicates the +B stop wire is operational. If it reads no voltage, however, it denotes an open circuit in the +B stop wire between the fuse in the underhood box and the brake pedal position switch, requiring immediate repair to maintain circuit integrity. Step 8 involves repeating the process of checking the open wire in the stop switch line. Once again, jump the SCS line with the HDS and allow it to settle for more than a minute. After that, disconnect the PCM connector A and press the brake pedal to measure voltage between the same 2 test points as before. If battery voltage is present, the stop switch wire is confirmed to be functioning. And it's essential to check for any detailed service information related to other DTCs or symptoms. However, if battery voltage is not detected, this signifies an open circuit, requiring a careful repair of the stop switch wire between the PCB and the brake pedal position switch. In Step 9, remove and visually examine the brake pedal position switch with the connector still attached. While doing this, press the rod of the brake pedal position switch to see if the brake lights deactivate. If the brake lights turn off when the rod is pressed, this indicates that the switch is installed correctly and functions as designed. You should then proceed to install the brake pedal position switch back in place and adjust the pedal height as necessary for proper function. However, if the brake lights do not go off upon pressing the switch, move to Step 10 for additional diagnostics, as this could denote further issues with the switch or circuit. The final troubleshooting step involves retesting the brake pedal position switch one last time for confirmation of its operational status. It's crucial to consider whether the switch exhibits normal behavior during this assessment. If the switch is tested and found to function correctly, it indicates a more complex issue, presumably a short to power in the stop SW wire. This scenario requires additional evaluation to fix the underlying problem. However, if the switch is found to be faulty, it must be replaced to rectify the issues associated with DTC P0571. This thorough examination ensures that all aspects of the braking system are restored to optimal functionality. After completing the troubleshooting and necessary repairs related to DTC P0571, verifying that the brake lights operate correctly is a crucial step. This involves turning on the vehicle and testing the brake lights multiple times to ensure they respond appropriately when the brake pedal is engaged. After confirming the functionality, clear any stored diagnostic trouble codes using the HDS to reset the system. Following the clearing of codes, it's essential to retest the system under various conditions to ensure that the issue does not resurface. This final verification ensures that both the repair work performed and the entire system are functioning optimally, restoring confidence in the vehicle's braking capabilities. For preventive maintenance related to issues stemming from DTC P0571, regular inspections of the wiring connected to the brake pedal position switch are essential. These checks help identify signs of wear, corrosion, or damage that could lead to circuit failures. Additionally, routinely testing the brake switch's functionality can prevent future problems from developing. Integrating these procedures into regular maintenance schedules will help ensure that any potential issues are addressed before they escalate into more severe malfunctions. Early detection not only maintains vehicle safety, but also enhances the longevity of the electrical components involved in the braking system. In conclusion, DTC P0571 indicates a malfunction within the brake pedal position switch circuit that should be addressed through systematic troubleshooting. Key steps include checking connections, testing the brake pedal position switch, and ensuring the fuses are intact. It is crucial to thoroughly test all components involved, as issues can often arise from wiring faults or switch failures. After performing the repairs, a comprehensive verification of brake light operation and a retest are necessary to confirm that the issue has been resolved. Following these meticulous steps guarantees vehicle safety and proper system functionality, ultimately delivering a more reliable driving experience. Please like and subscribe to the channel. See you next time.